Is China's new technology, new telescope, fast telescope, the key to finding self replicating swarms of extraterrestrial alien robots? One of the most challenging questions to answer when confronting the Fermi paradox is why exponentially scaling technologies have taken over the universe by now. This by Andy Thomaswick, Universe Today at Sun Science Alert. Commonly known as the von Neumann probes, the idea of a self-replicating swarm of extraterrestrial robots has been a staple science fiction decades, and so for now there's never been any evidence of this existence outside of the realm of course, science fiction. That might be because we have not spent a lot of time to look for them, and that could potentially change with the next new 500-meter aperture spherical radio telescope, FAST for short. According to some recent calculations, the massive new observational platform might be able to detect such swarms of von Neumann probes relatively far away from our sun. Those calculations carried out by Dr. Zaraza Ozamov of the Free University of Tbilisi in Georgia showed that von Neumann probe swarms for highly advanced civilizations could be visible in the radio spectrum band that is the focal point of the telescope FAST. And to help in the search, Dr. Osmanov used two frameworks to bound the potential solution. The first was the idea of Kardashev civilizations, while the other is estimates of the thermal and electromagnetic emissions profiles of any such swarm. The Kardashev scale is a well understood concept in science speculation. It focuses on civilization types over energy use with different milestones, type 1, type 2, type 3, etc., correlating with the utilization of entire energy output from a planet, a star, even a galaxy. Currently, human civilization is thought to be around 0.75 on the Kardashev scale. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So we're not even a 1. But given the relatively limited amount of time humans have spent developing on the planet, there's a very high likelihood that if life exists elsewhere in the galaxy, it will have had a much longer time to evolve and develop technologically. Larger technological development times lead to a higher likelihood that a civilization would reach K2 star energy or even K3 galaxy energy levels of development, Kardashian K2 and Kardashian K3. When a civilization has that much time to work on new technologies, it most likely will have developed the ability to create self-replicating machines, like a von Neumann probe, as part of that technological development process. Once that technology cat is out of the bag, it is almost impossible to put it back in. Even if one civilization releases them upon a galaxy, the self-replicators would likely begin to expand to every available resource, focusing solely on their own reproduction. And according to Dr. Osmanov, we would at least be able to see any such path of destruction coming. Like all imperfect systems, those self-replicating machines would emit some form of radiation, which after some simplifying assumptions Dr. Osmanov calculates should be visible in the radio spectrum. Specifically, he says it would fall right in the middle of the spectrum that the FAST telescope is designed to pick up. Knowing that it will be possible to detect a swarm is only slightly helpful, though. Knowing how far away you can detect it is much more useful. Like with potentially dangerous asteroids, the sooner we can be made aware of the impending doom, the better to combat it, at least to mitigate it. So to try to calculate the distances, Dr. Osmanov made some more simplifying assumptions, such as the maximum power output that could be expected based on the Kardashev level the civilization has achieved. For example, a Type 2 civilization would not have a von Neumann cluster emitting more light than their entire energy utilization level as defined by the scale. With those additional assumptions, Dr. Osmanoff finds that the FAST telescope could potentially detect a self-replicating robot swarm for both Type 2 and Type 3 Cardassian civilizations. Considering the expected sensitivity of the FAST instrumentation, it should be able to find any such swarm within about 16,000 light years for Type 2 civilizations, meaning any Type 2 probes would be visible within the closest 15% of the Milky Way galaxy, our galaxy. On the other hand, a swarm created by Type 3 civilization would potentially be detectable within a 400 million light year bubble, encompassing most nearby galaxies. So far, Dr. Osmanoff's paper has only been published on ARXIV and does not appear to have been accepted by an academic journal, meaning these calculations have not been peer-reviewed. But they still offer a fun thought experiment to point to a potential detection mechanism for some black swan-like events. While it might be comforting to know that we would be able to see any such encroachment danger with FAST telescope well before it threatened our Earth, there remains the question of what happens if we do find them? What happens if we do find them? And what does that mean for our place in the universe or the development of self-replicating technology? So if you don't want to learn more about that, you can take a look on the ongoing Beyond the Fermi Paradox series written by Matt Williams. It's thought-provoking into some of the implications of some of the biggest questions out there. It might even be engaging enough to entertain a swarm of self-replicating robots. This was originally published on Universe Today by Andy Thomaswick, and it's on Science Alert. Please leave your comments. Thank you for your support.